Hi guys, welcome back to another CalcFly video. In this video we're going to be talking about question 1 from AP Calculus 2018 for response portion. Okay. Alright, in this problem, people enter a line for an escalator at a rate modeled by this given function. So basically this is going to be my rating function. And also, as people get on the escalator, they exit the line at a constant rate of 0.7% per second. So this is my rate out function. Okay. And also, there are 20 people in line at t equals 0. All right. So let's quickly dive into the first problem, part A. How many people enter the line for the escalator during the time interval? So basically, this is going to be accumulation problem, and also we're focused on specifically rate-in function. So my rate-in function is r of t. All right. So basically, we're going to calculate this definite integral. So part A, from 0 to 300 r of t dt. Okay, so that's going to give me my the number of people entering the escalator. So this is going to be equal to, if we grab the calculator and calculate that, this is going to be equal to 270. Okay, 270. So basically my reasoning is, according to the model, 270 people enter the line for escalator during the time interval 0 less than or equal to t less than or equal to 300. Okay. Alright, let's move on to part B. In part B it says, during the time interval, this time interval, there are always people in line for the escalator. Alright, because we know that there are 20 people already in line at t equals 0. Okay, so how many people are in line at time t equals 300? Okay, so basically, in order to calculate that, I should be able to set this up. So initial number of people, okay, plus and this integral, definite integral from 0 to 300 r of t minus 0.7 dt. Because this 0.7 is my rate out function, rate of change in the number of people exiting the escalator, and this r of t is the rate of change in number of people entering the escalator. Alright, so this result is going to give me the answer. Like, this expression is going to give me the answer. So basically, if I use my calculator, this is going to be equal to 80. So according to the model, 80 people are lying at t equals 300. Okay. Alright, so let's move on to part C. It says for t is greater than 300, what is the first time t that there are no people in line for the escalator? So we know that that's going to be sometime greater than 300. So we also know that at t equals at t is greater than 300, r of t is equal to 0. So r of t is equal to 0. Remember that. For the t values that are bigger than 300, r of t is equal to 0. So there are no rate-in, but still there's rate out. Alright, so basically the thing that I'm going to set up is, to be able to solve this problem, part C, 80, okay, plus, because 80 is the number of people at t equals 300. So from 300 to sometime that we're trying to figure out, there is no rate-in, so I'm going to put 0 minus 0.7, there's still rate out, dx. And this result this expression has to be equal to 0, because it says there are no people. So again, if we grab our calculator and solve this, we're going to get that's going to be equal to approximately 414.285 approximately. So, okay, that's the time that we needed to figure out. Alright, let's move on to part D. So in part D it says for 0 is less than or equal to t less than or equal to 300. At what time t is the number of people in line a minimum? Alright, so we've come across a minimum or maximum problem. So in this case, we're we're specifically focusing on minimum. Alright, so to the nearest whole number, find the number of people in line at this time. So let me clean up this top here, up here, so we can work this out. Alright, so part D. So the total number of people in line at any time t on this interval, okay, is modeled by 20 plus from 0 to t, r of t, actually, sorry, this is r of x. Let me clean this up a bit. So, r of x minus 0.7 dx. Okay. Alright, so if I set this expression, if I take the first derivative, because it says minimum, okay, so the finding minimum or maximum, that is directly related to the first derivative. So if I find the first derivative of this expression with respect to time and set this equal to 0, what are we going to get is r of t minus 0.7 is going to be equal to 0. And from here, if I solve this equation for t, we get t1 is equal to 33.013, and t2 is equal to 166.575. Okay, so now we're going to test these values at these critical numbers and also these endpoints. Alright, so let me clean up the board, this part. So, t and people in line for escalator, okay. So that's going to be equal to, first t value is 0. So when I plug this in, I'm going to get 20, because we already know that there are 20 people at t equals 0. And the second t value is, I'm just going to put the t1 and t2, and also 300, I'm sorry. So if I plug in t1, which is this value, okay, into the r of t, what are we going to get is 3.803. And if I plug in t2 into the r of t, we're going to get 158.070. We already know how many people are in the escalator at t equals 300, which is 80. So we got this in part B. Okay, so it says minimum. So basically, the number of people in line is minimum, and notice that is minimum at t equals 33.0113. Okay, so all right. In this problem, part D, we focused on how to figure out the absolute minimum. So the absolute minimum value is the the least, the smallest number of people entering the escalator. Alright guys, thanks so much for watching this video. In this video, we've specifically focused on question 1 from AP Calculus Free Response portion 2018. In this problem, we've come across some concepts, the accumulation, rate in, rate out problems, and also absolute minimum. Thanks so much for watching. Don't forget to subscribe, like, share, and comment. Bye-bye.